Alright, good afternoon everyone. My name is Jeremy Leon Palomino, and it's about time I uploaded something on Math Squared. You can trust me for the most part, because I got a 5 on the AP Calculus AB exam. Currently I have an A on BC Calculus, so, and a name AP Physics, so you can probably trust me with most of the explanation that I will try to do. And one of the big takeaways I want this to be is a learning process for not just people who watch this video, if anyone watches it, but necessarily a experience that I can gain as kind of a mentor / tutor, and grasping some knowledge for myself, not only in the field of obtaining how to, one, be more vocal, and teach better, explain things better, but two, need some tea, but two, kind of going through the learning process myself, because one of the biggest contributors to the joy in my life is mathematics, and a lot of times you see that with the right teacher, you go from hating math to loving it. Personally, I've always loved math. When the teacher was bad, I just studied it myself, but thankfully, I had the best AP Calc AB teacher last year, Mr. Heffron. He didn't die, but he switched schools. And currently, Mr. Sear, he's actually a really good teacher. There's just experience difference in years of teaching between Mr. Heffron against Mr. Sear. But they are both intelligent people, so hopefully I will grow more curious with them, and yeah, let's get started. So it's kind of like a test video, because, well, I'm seeing kind of how I want to record this. Right now I'm currently using my phone. The next thing I want to do is try the graphic tablets and see which one's more efficient, but I believe personally that probably just writing with my pen is quicker, and in life each minute is valuable. So yeah, this video is going to be about a topic covered in Calculus Semester 2, or BC Calculus, AP Calculus BC, and it's called Integration by Parts. So yeah, it kind of comes back and bites you in the butt, because before we learned integrals, right? Just like basic integrals, like the integral of sine of x dx is equal to negative cosine of x plus a constant if it's a indefinite integral. They come back way more challenging, and it's going to get even harder as far as I know. So this is what I mean by going through the learning process with you guys, is I can kind of grasp things quicker and retain things like this. But yeah, this at this point should be common sense if you're watching this video. If not, the reason cosine of x is the integral of sine of x dx is because the derivative of negative cosine of x is positive sine of x. So yeah, so this is actually going to be called integral by parts, integration by parts, and the formula, and I'm going to explain a little why I use this formula above, but it's the integral of u dv I'm going to go and change the colors for dv, but it's equal to u v minus the integral of du duv. That's the formula. Now I'm going to give two problems in this video. The first one is going to be the integral of x sine of x dx. Okay. Basically, the biggest thing here is picking the right u and the right dv, because what you choose for u, obviously the other function is going to be dv, and you want to choose a u that will get simpler as you go on and differentiate and take the integral. So in this case, I'm going to give you a little acronym that I learned from one of these YouTubers, but it's a better name, but it's LIDE. So u is going to be whatever LIDE is in order. So it goes logs, inverse trig, algebraic functions, trig functions, and exponential functions. In this case, when you look here, you see x to the power of 1, that will be an algebraic function, and then sine of x, which is a trigonometric function. When you look at u, which one comes first? Well, here's algebraic, and here's trig. Algebraic is before trig, so we're going to go ahead and choose x as u. So, we know our u now is going to be x. Now we have to figure out what du, what du, dv, and v will be. And as I stated earlier, dv is just going to be the other function, so it'll just be sine of x. So dv is sine of x dx. And v is going to be the integral of that, which we set up here was negative cosine of x plus c. But we're not going to put plus c here yet. So that's negative cosine of x, and du is 1. Now if you don't know why that is, it's because x power of 1 dx. So we know the formula for this will just be x n, n plus 1 over n plus 1. And I'm dumb. No, I'm saying the integral of this when this is the derivative. Ignore this. So why does x go to 1? It's the derivative. So it's actually x n minus 1, and then just n. So x to the power of 1 minus 1 times 1. So it's going to be 1 times x, 0, and anything to the power of 0 is 0. So 1 times 1 is equal to 1, and that's du. Yeah, I was like, wait, what am I doing here? But, alright, so now we know u, du, dv, and v. We're just going to go ahead and set up our new function, which will be uv negative x cosine of x minus the integral of duv, so 1 times negative cosine of x dx. Alright, that's what we have right now. Now, the integral of negative cosine of x dx. What trigonometric function's derivative would be negative cosine of x? Well, we know the derivative of sine of x is cosine of x. So if you just put a negative to negative sine of x, the derivative of that will be negative cosine of x. So the antiderivative of negative cosine of x dx would be simply negative sine of x. You can see here. Okay. So now we're going to go ahead and just finish putting these things in. Negative x cosine of x minus negative sine of x. So negative times negative is positive. So plus sine of x. And since it's an indefinite integral, you always have to add the constant. And this will be your integral for x sine of x dx. Now, how about when you have the integral of x e to the x dx? Well, common knowledge for math, and just if you didn't know this, you will now, is that the derivative of e to the x is always e to the x. So let's say this is f of x, this is f prime of x. And so that means that the antiderivative of e to the x is simply e to the x. So now, we're going to go ahead and look here. Which one of these come first? Well, e to the x is an exponential function, and x is just an algebraic function, and that comes before an exponential function as stated here. So, again, our u is x, our du is 1, our dv is going to be, well, you'll find out, because, it's e to the x. So, like I said earlier, the integral of dv, which is e to the x, as said here, is simply e to the x. And don't forget the dx here. So, now we're going to go ahead and use the formula again. So, uv, x e to the x, minus the integral of duv, so 1 times e to the x dx. What will that equal? Well, again, we see that the integral of e to the x is back. And what does that mean? It's simply e to the x again, plus a constant. So this is one of the more basic, actually this is super easy if you just know the formula and know common derivatives and integrals. But as we move on, you get into the concept of boomerang integration by parts. And simply what that means is they will be repeated again, and there will be problems where you need to use integration by parts twice, and there's some that you can't even use this method or any other method, which we'll cover later on. But yeah, seldomly this is division by parts, like an introduction to it. So yeah, if you have any questions, go ahead and leave a comment. I don't expect many people to see this, but yeah, have fun with math.